Welcome, everyone. Today we have Hal Varian. You have 50 minutes. Take it away.
Okay, so thank you very much for inviting me to speak at this meeting. I haven't worked in this area for some time, so I'm really looking forward to your reactions and references. But I'll tell you what motivated me to work on this particular problem. Whoops, let's see if we can get this. Oh, there we go. Okay. The Competition Market Authority produced a document, very long, very interesting, really quite a good document too, I think, describing how search works online and online advertising works in general. So one of their points is that higher advertising prices matter because they increase the cost to firms, and we would expect those costs to be passed through to consumers in terms of higher prices. And will face, they don't say may face or shall face, they say will face higher prices for items such as books, games, smartphones, televisions, and so on. And they repeat this in several places in this document. Really, their theory of harm from this alleged monopoly is, in fact, these higher prices that consumers will face. But is there pass-through of ad costs? As you know, the literature says, well, it depends. It depends on your model. Sometimes there is, sometimes there isn't. So we can ask empirically, have ad costs increased over, let's say, the last decade? And then if the ad costs have increased, we might ask, are the prices of goods advertised online increase? Has there been pass-through in the actual economy? We can also write down a little theoretical model. In one case, a very simple Econ 101 model, which I'll give you in a minute, and then something that's slightly more complex. And down here at the bottom of the page, I've listed some of the literature from the that I found. There's this nice long survey by Bagwell that references most of these papers. And then there's a more recent paper by Roach, R-A-U-C-H, I think that's Roach, that describes some of the more recent work. Okay, so let's jump right in. So let's look first at this question of the price of ads, and we can look at the expenditure on advertising in the US. This is a paper by Michael Mandel at the Progressive Policy Institute. Turns out that the ad prices have gone down very substantially. Sorry, the ad expenditure has gone down very substantially. And when I say advertising expenditure, I mean a share of GDP. It's historically been around 1.2%, and now it's down beneath 1. So it's a fairly striking result, I think, and that's true in Australia, US, France, Germany. In UK, it hasn't gone down to the same degree, but it stayed relatively constant. And in fact, Bloomberg has this terribly ugly graph that shows that really ad expenditures as a function of GDP has been around 1.2% for a century. So we don't see any striking changes now. If anything, we see this decrease that was documented in the last slide. The CMA said that consumers will face higher prices for books, games, smartphones, televisions, flights, hotels, and home insurance. I went and looked at the Consumer Price Index in the US, and none of that has actually happened. We've seen dramatic decreases in prices of games, telephone hardware, television. We've seen increases in hotels and home insurance, but the increase in hotels and home insurance is just the same as the overall average ad price increase. So, obviously I don't really take this seriously because there are lots of other things that could reduce the price of televisions, hardware, and games. But just to show you that on the face of it, it doesn't seem that they've really gone up at all. In fact, mostly they've gone down in the last decade. And finally, there's a recent paper by Goolsby and Klenow that says online prices have fallen much more than offline. They were able to get this nice data set that showed offline transactions, and they compared their digital price index to the consumer price index. And as you can see in this chart, the prices online for those transactions, telephones, books, TVs, toys, games, and computer software, they've gone down substantially more than the CPI. So online prices of goods have fallen more rapidly than offline prices. Okay, and in fact, there's the chart showing the CPI, Consumer Price Index, and the Digital Price Index, which is based on this online transactional data. And we know from other studies that generally advertising prices often leads to lower prices. So the classic article is on eyeglasses. In some states, you can't advertise eyeglasses prices, at least. In some states, you can't advertise liquor prices. Some places you can't advertise legal services prices. So there is a variation among the states about what you can advertise, and where you can advertise the prices. And those states where price advertising is legal show typically lower prices for these products. Now, the interesting thing is online, not only is price advertising allowed online, it's actually mandatory for some ad formats. So the product listing ads from Google, Bing product ads, Facebook product ads, Amazon sponsored product ads, those all have to show the price. And as we've seen from the previous literature, generally showing the price is going to lead to a reduced price through forces of competition. Two more references. One is a paper by Nakamura et al. He's at the Bureau of Economic Analysis, looked at valuing free media in GDP. And basically what they found was really there was a total amount spent on media did not go up dramatically. It just shifted from being mostly offline advertising to mostly online advertising. So you're not changing the total spend, you're just moving it from one bucket to another. And you would think there should be no impact on costs from doing that because the total costs haven't changed. But, and in fact, that's indeed exactly what they found. And finally, the CMA report itself says that Google's cost per click has been fairly stable. So even though they cited this as a source of harm, they also pointed out that it really doesn't seem to show up in any of the data, at least so far. Okay. So that's the empirical overview, very quick. And now I want to talk about some of the reasons you might think that might be suspicious about this claim. So let's start with hiring a worker. Okay, will the labor cost for that worker be passed through to the price of the goods produced? Or would we expect that the worker was hired in order to produce more revenue for the firm? The marginal revenue product was greater than the wage rate, thereby offsetting the wage costs and leading to increased profit by the firm. So when you hire an additional worker and you're making a positive profit margin on the firm and the marginal revenue product of the worker exceeds the wage rate, you would expect to see profits go up, okay? Expect to see profits go up, but you wouldn't really expect to see any cost through prices. Why? Because you're putting more of the good on the market. And second point is, if a firm is able to increase prices in order to offset an increase in cost, investing in anything, but let's say advertising, well, why does it just increase the prices without the advertising? Hires it before the price goes up. So if you're able to raise the prices and pass along a cost increase, you could have just raised the prices and made more profit. Third point, does advertising help inform consumers about prices, features, availability, so on? I think the answer has got to be yes, and that says you have a more competitive economy due to the points above and due to the points in the previous slides. And you know this old puzzle from grade school, which weighs more, a ton of steel or a ton of feathers? And the answer is, well, they both weigh a ton. So if you have a $10 million TV campaign and you have a $10 million online campaign, it's the same $10 million. So when you see this shifting from TV, shifting from news and so on online, total amount of money spent has gone down a bit, as we saw from the price index. So there's nothing to pass along in my view. Okay, So that's the introduction. Let me talk now about a simple model that you might use to examine this claim. So as you know, everybody again in this audience, there's at least two types of ads: a persuasive ad that modifies a consumer's willingness to pay for the product some way, and an informative ad that seeks to make the consumer aware of the product, its features, and how to acquire it. That's a quote from this Roach article that I alluded to earlier. And generally speaking, economists are a little suspicious of this persuasive view. If you're changing the preferences to shift demand out or increase the probability to click or whatever it is, increase monopoly power, any of those things, generally economists would be pretty suspicious of that. While on the other hand, informative advertising increases information available to consumers, leads to stronger competition, as in the examples I cited earlier, and certainly could easily move to lower market prices. But and even the consumer, the competition marketing agency recognizes this distinction. When advertising improves information available to consumers, it will improve consumers' knowledge and understanding, helping to grow demand and improve consumer welfare. But when you look at it, most online ads are informational ads, the good kind of ads that help people shop around and find lower prices and increases consumer welfare. So again, when we look at the theoretical literature, generally speaking, informative ads for sure are likely welfare enhancing for consumers. And this whole idea of passing along doesn't really make much sense, because if you invest in informational advertising, you expect that investment will increase your sales, revenues, and product. That's why you're investing in the advertising. And that's the case for persuasive advertising as well. And if the merchant chooses to raise prices, it's because a persuasive ad has been effective in communicating to the consumer that this perfume will make you more desirable, or these clothes will make you look better. But it's not because the ad has been costly, it's because the persuasion has been effective. So the passing along terminology used by the CMA and other parties is about what happens to costs without looking any regards to benefits. The benefits are, in fact, helping consumers find products they want, this informational advertising that I alluded to before. So it's not like passing along a tax, because a tax is a pure cost without any offsetting benefit. But instead, it's like looking at the benefits that you get from the advertising, comparing that to the cost, as with any other factor of production. Okay. So now, after all that polemic, I'm going to give you a very simple model. So there's a large population. You could think of it as an infinite population of consumers, and there's a distribution of willingness to pay. So the advertiser pays a platform some amount of money, M of N. N is the number of consumers. M is the amount of money that they pay. And that platform will send an audience of size N to its site. So it could be a TV show that people see the ads interspersed in the TV show. It could be a newspaper, it could be online, it could be anything. But I'm mostly thinking about online. That's my motivating example. So let D of P, that's going to be a demand function, but not your ordinary demand function. Ordinary demand function says the number of people who will purchase at price P. This is going to be the fraction of the audience that will purchase at price P, okay? So it's a kind of a normalized demand function. And, 1 minus the cumulative distribution, to be exact, I guess I mentioned that down below. And how do you estimate that? How do you estimate that demand? Well, you sample. You sample a set of consumers, and you propose different prices to them, and you see which ones will purchase at those proposed prices. And that's a very common way to actually engage in pricing. You're not given a demand curve, you're given a sample of consumers, and then you can use various kinds of experimentation statistical methods, but you can estimate how many people of that group will purchase at a given price P. And of course, that sample can be stratified on things: men, women, demographics, age, location, et cetera. But mostly we'll be thinking about it as trying to draw a random sample from the population. And then we look at the CDF for that, and we say 1 minus the CDF, that's going to be the demand fraction I mentioned earlier. Okay, so taking all that as given, what's the profit then? Well, the profit is price minus constant marginal cost for convenience times this unit demand function, this normalized demand function, times the number of people in the sample, minus the cost that you have to pay to the platform to acquire that audience. So it's your margin, price minus cost, times the sales, which is the unit demand times the number of people in the sample, minus the consumer acquisition cost, this M of N, how much it costs to acquire that audience. Okay, so here's the neat thing about that expression. The decision turns out to be nicely separable. So what you do is you first find the price that maximizes the profit per person. So you maximize price minus marginal cost times unit demand, okay? And that gives you the optimal price. And then you decide how many customers you want to acquire, which is the second expression there, maximize over N, the value per person times the number of people minus the cost of acquiring that number of people. So right away, that tells you the product pricing is independent from the marketing spend, okay? First, figure out the price. Once you know the price, you know the profit per person, then you look and see how many people you can get, taking account of the cost of acquiring that audience.
So Hal, can I ask a question? So of course, that is all true if the money that is spent on advertising is not really dependent on how many consumers in the end.
The money per person, yes, the money per person.
Money per person.
Yes, that's right.
Exactly.
And that's critical. That's of course.
But you can think of other.
You can have an effect on the extensive margin, no, of advertising.
And that's what I'm going to talk about on the intensive margin and the extensive margin. The intensive margin, I think you mean. No? Anyway, yeah, it's right. You could change the amount that a consumer buys, but I'm looking at this discrete choice model.
You can have an effect of advertising on the number of consumers that buy at any price. And this is, you don't do it.
Well, okay, so I described something like that. This is my baseline model. It's not the only model that we're going to be. So I will look at something in 5 minutes that will is along the lines of what you're suggesting.
Sorry,
okay.
Martin. Sorry, Martin.
Okay. Okay, so let's look through this model. How do firms actually determine prices? Well, they'll often set up a focus group. They ask people whether they buy or not. Maybe they use conjoint analysis, which is like revealed preference analysis. They might use surveys, comparison products, and so on. But they do like to get a random sample of the segment that they're trying to market to. Now, maybe that's the whole population, but that's what they want to get, a random sample of the population. It might be only men, they get a random sample of men. It might be only 50 to 60-year-olds, they get a random sample of that, and so on. And so if you make the sample size twice as large, you'd expect to get twice as many sales. You get roughly the same optimal price for the product, and you make twice as much revenue and profit when you have a constant marginal cost. And that's something like the central limit theorem. It's not exactly that. Sorry, the law of large numbers. It's not exactly like that. It's what you'd call the Glivenko-Cantelli theorem, which says your sample CDF converges to the population CDF as you increase the size of that sample. So this point above, they would think of things as basically scaling in a proportionate way. Twice the sample, you get twice as many sales, but you'd have the same optimal price in general for a large sample. Okay, so I think everybody would agree to that. It's pretty simplistic, but it's a very useful model because it gives you a very immediate answer to the question that we started out asking. And you can prove that it's separable if you want, but on the top line there, I wrote down the optimal price and quantity, optimal price and the optimal audience size. That says it's optimal, then I proceed to cancel things, and I end up with the fact that you have to be maximizing margin or profit per consumer if you're solving that overall maximization problem. And it's just like utility separability, where you can look at a separable subset of the utility function. Okay, and you can do this if you write down a calculus. You've got a profit is revenue per person at the price P times the number of people minus a parameter B. Parameter B is going to be used to shift that cost of acquiring an audience, but then the expense is simply that cost. And it might be, I'm kind of neutral at this point. Is that an internal cost that the firm does itself, or does it hire a marketing agency who does it? We can look at a couple different cases in a few minutes. So obviously you want the revenue to be optimized, first order condition is given there, and you want the revenue per person to be optimal, and then you want this choice of the number of people to be optimal. And in fact, you get a nice little expression because of the fact that the price is independent of the number of people that you sampled. The optimal prices does not depend on the sample size in expected terms. Then you get the fact that this M prime of n has to equal this constant R of the P star over B. And so when we move P star to look at the, when we adjust B to look at the comparative statics, you get a nice formed expression for that. Okay, so equilibrium looks like marginal revenue equals marginal cost, big surprise. Marginal revenue is the pricing part, the marginal cost is the audience size, and you find some optimal audience size and some optimal price, and there's some producer surplus there that you could look at. The producer surplus is in light blue, and as you shift those marginal costs or the marginal revenue around, you can see how the comparative statics will work out. I'm not looking at the consumer side. Okay, I'm not looking at the consumer side. I'm only looking at the advertiser side. But the consumer would see more or fewer ads depending on the audience size you purchased, and that could have some consequences for surplus. I'll make a couple remarks on that in a minute. Okay, so that's the informative advertising. Let's look at persuasive advertising. Same thing. Just take the expenditure on a persuasive ad. We're going to call that X for expenditure. And now your margin is price minus marginal cost minus expenditure on the persuasive ad times the demand. Demand function now depends on the amount of money spent in persuasive ads, not only on the price of the product. And you get the same separability. You maximize over P and X of what your creative looks like, what your persuasive ad is like. X can be almost anything that shifts demand. And then once you've decided what the message of the ad is going to be, and you decided what the optimal price for the product is going to be, then you do the same thing, solve for the unit, price per profit per person, and then you look at that and plug that into the marketing decision and see how many people you want to attract at that price. So just persuasive advertising works fine too. But of course it won't work, and this is a point that Conrad raised earlier, if n enters a demand function in some arbitrary way. So if demand depends on price and the audience size, then you've got an interaction between these two factors, and you can write down what the first order conditions look like. You can look at the comparative statics very easily, but you just you don't get that nice clean separability. And I'll give you an example, explicit algebraic example in a few minutes. Before I do that, I want to explore this baseline model a little bit, and I want to look at market structure. If you look at the product market, it could be monopolistic or competitive, okay? If you look at the marketing services that are provided, that is the agency that provides this audience to you, that could be monopolistic or competitive. So there's 4 cases we want to look at, and we might ask, when do we get a higher price? When do we get a lower price, etc. Okay. So let's suppose that we have a monopoly on the marketing side. So now we've got, remember that shifter B that I referred to? We're going to think of the actual cost to the marketer as being M of N. And then we'll think of the markup that the marketer makes. Remember, this is the person who's providing the audience, not the person who's providing the product. Anyway, the marketer charges B times M of N, where B is greater than 1. So it marks up its actual cost, and it has some monopoly power that allows it to do that. So what happens when you go through in fact, you can just look at that marginal cost and marginal revenue curve and shift the slanted line. And what happens then is the audience size becomes smaller, but the product price still stays the same. So this is saying when you increase the cost of advertising, people do less advertising. Okay, that's true of any factor of production. It's in microeconomic analysis. Under very general conditions, the factor demand curve sloped down in this particular condition, in this particular problem. When you increase the price of marketing, people do less marketing, but they don't mark up the product price. Product price has already been determined. If they could have marked up the product price and made more money per person, they should have already done it, right? So that's the story here. And I know Conrad mentioned that, well, maybe P depends on N, but if you think about what firms actually do, they set the price first. And once they're happy with the price, then they go out and they figure out how many consumers they want to market it to, given the cost of marketing that they face. Next model is we could look at what happens next market. Oh, Heskey, you raised your hand. Go ahead, ask the question.
Yeah, so I have 2 things. I mean, one thing is in terms of informative advertising, one form of informative advertising sort of segments the market a little bit. So, we find customers who are predisposed to like our goods. So that kind of market segmentation can lead to higher prices. So that was one observation. Informative doesn't just mean awareness necessarily. We have this demand rotation stuff of Johnson and Myatt and others that is going to have a price effect. So that was one observation. A second observation is here and maybe you're coming onto this, you're taking the set of goods in the product market as fixed.
Oh, yeah.
If we raise advertising costs, that can have an effect on what goods are on the market and what residual demand looks like and so on.
Yeah, so you're absolutely right. I mean, those are outside the context of this model because this model is extremely simple. And there are other structural models where you naturally get you naturally get the let's say, demand function as a function of the size. So I'll give an example later on, but just think of something where you have a hoteling-like model, and then in a hoteling-like model, it could well be that the demand curve shifts as you increase the size of the market that you're advertising to. And as I said, I'll give some examples of that. So those things can certainly happen, no question. It's just here I wanted to look at what I think of as a baseline. What I think of as a baseline case.
Can actually also just, I guess sort of in a similar vein, what I was thinking of more is, you seem to have assumed homogeneity of consumers in a sense, right? So if you have more consumers.
No, not. You've got this whole random distribution of willingness to pay, And as you pick a different price, you're going to see the people who are willing, who value the good at least that price. And so the price is going to be the same as you change the size of that sample, as long as you've got a truly random sample. So there's no homogeneity in consumers.
Random sample, I guess, yes. So I guess what I was thinking of is more the random sample. So if I start marketing, if I don't spend much on marketing, maybe I would first, market a particular group that has particular type of demand function. If I now extend my marketing, I would then go to sort of the next group whose demand function might look quite different and so on. And, that's sort of a simple way in which somehow market, therefore the optimal price is going to be correlated with what is going to be my optimal, with the marketing I do.
Yeah, so that's right. That's where I said that the slope of the demand curve depends on the size of the market. That would be a case where you'd violate this. You'd have to put that N inside of demand. But remember, in this case, the demand function just comes from the distribution of willingnesses to pay. You look at 1 minus the cumulative distribution function. That's how many people have a price, have a value that's greater than that price. And then as you change that price, you get a change in the amount of purchase. You can see what it takes to maximize margin times the demand. But the consumers are very heterogeneous. I mean, the simplest case is to have a uniform distribution of willingness to pay. Then you get a linear demand function, because the distribution function for a linear example, the CDF is going to be a straight line.
Sure. Yeah,
I mean, that's absolutely standard. And so you could draw any kind of demand curve you want. There's an optimal price, at least one optimal price. There's no claim for uniqueness here. You can put in an assumption that would make it unique. And there you are. So it could be a very heterogeneous group.
Quick
Go ahead,
question.
Sandro. Yeah.
Hi. So I'm still not fully convinced why this model is a good descriptor of the world of online advertising. And I'm going back to what Martin asked about kind of fixed cost of advertising versus marginal cost. So imagine that, I mean, this is a completely imaginary world that is hard to imagine, but imagine that for advertising, you have to pay every time consumer clicks on your ad.
Mm-hmm.
And now further imagine that probability that the consumer clicks on your ad depends on your price.
Mm-hmm.
Okay. So now if a per click cost of the ad increases, this changes your pricing incentive, because basically now the cost of this click is like a marginal cost, which is very different from the model you have, where basically costs are fixed and therefore clearly they drop out from profit maximization with respect to price.
Yeah, there's two things there. There's the kind of production cost, which is the C, that's the marginal cost there, and then there's the cost of acquiring an audience of size N.
Right, but that's in this model. But I could imagine a model where the cost of acquiring a person depends on the price, and therefore now optimal price depends on the cost of advertising. And it's not completely crazy to imagine that the kind of the offline advertising world was more of the fixed cost kind. You would just throw things at people and then you would set price. Whereas the online world is more of this variable cost kind, where now the variable cost could conceivably be passed on to consumers, not in a sense that, I mean, you're right to say that, if they wanted to increase the price, they could have done so, but the pricing incentives change in a sense that their marginal consumers cost them some money via advertising per click, and that changes pricing. So
this D of P is kind of a reduced form of that. It's how much people buy if there's a price P. It's C, and then you find the optimal price given how much people purchase. It could be a click. You could say my audience is everybody who's issued a search on the word frying pan. So that's my audience size. I want those people. You could say, I want people who search for frying pan and who search for skillet. Okay, that's going to cost you some money too, because you're going to have to attract these people to your particular ad and so on. Same thing on TV. If I want an audience of women 25 to 30 years old, that's what they're offering. They say, here's this audience size. If you put your commercial in this TV, this is how many people you will see, how many women from 20 to 30 years old. So what you're doing is you're fixing the price for your product used on your estimate of what the demand function looks like. But then you're choosing the size of your audience depending on what your goals are. And
So
I'm not saying this is the only possible model. I completely agree with you. There are other ways that you could formulate it, but
I think there are ways to formulate it such that the advertising cost would be added to the marginal cost in this maximization problem we see here, and then price would reflect the advertising cost because it's per click, which depends on price, as opposed to the old model where, okay, I want to advertise to single women and I just spend some money on it, but how many of them will end up purchasing does not depend on the how much it will cost me to advertise does not depend on the price that I choose, which is not the case in the per click world.
yeah, but as I said, I don't think there's any reason to put clicks in there. That could be like views of an ad on TV if you want. I just want to say the demand function is how many people will purchase at a given price P1 normalized by dividing by the total number of people. And if I have a bigger sample, it could cost me more. That M of N function is sort of naturally a convex function. But if I get twice as many people, roughly speaking, I'm going to get twice as many sales because I'm taking this random sample from the population, and that just follows from elementary statistics. So I specifically didn't want to put in clicks or views or any of these other things. You could put that in, and you could say, well, the views or clicks depend on something else, and that's going to influence the ultimate probability of purchase, because that's what I care about, the probability of purchase, not where that probability comes from. So, okay, so we'll talk more about this point, because this is I think it's fairly critical. I'm trying to make as simple a reduced form model as possible to get some insight into this problem. And it definitely could be more complex. All right. Bertrand competition. Now we have two marketers. They have the same technology, let's say. And what happens is that they compete and just do the usual Bertrand competition. You get to a outcome where B, that shift parameter, ends up equaling cost. Any price, any situation where B is above B1 or B2 is above 1 can't be in equilibrium because one of them could just cut their price. So that's standard Bertrand stuff. But you still get the product prices determined independently of the market size. And you can look at Cournot models, you can look at everything else, because the separability says, okay, you tell me what the prices are, I'll just stick those into the first part of that equation, and we still get that Bertrand model coming out. Sorry, we still get whatever we put in, whether it was Cournot or whether it was Bertrand or whether it was some other oligopoly model, that's going to be separable from the audience size choice. Okay. And then what is this about? Oh yeah, so if you want to do examples, then I do need to do an example because I can't get an analytic solution for the competition and product market case. Let's assume that M of N is quadratic, so it's N squared times its B. We've got an audience size. If we think about what equilibrium would look like in a competitive product market, there's two things you need to decide, and the two things you need to determine. You need to determine the price, and you need to determine the the audience size, okay? And if we assume that that demand function comes from a uniform distribution, okay, uniform distribution gives us a linear demand curve, intercept 1 and slope -1. And then we've got demand equals supply as another issue. So you've got the audience size is one thing that has to be determined, demand equals supply is the other thing that has to be determined. I assume a linear demand, I get simple little quadratic equations, and we end up with one curve showing you the combination of P and N that gives you demand equals supply. Remember, there's a demand equals supply in a product market, and we can look at that for different size of the audience. Audience size where you have B equals 1, other audience size you might have B equals 2, and then you can determine what the equilibrium is in this market. It's a diagram exactly like that. Now it's a little bit messy because you can get multiple equilibria. That blue curve is shifted up. You could see it would intersect one of the yellow or the green curves, but that's just the way it is. There's nothing much we can do about that. You can write down conditions that give you unique equilibrium, just in sort of the obvious conditions. What can we say? I can't even read that. Oh, yeah, the one thing you could do, so let's go to that problem. Now we have a specific P times 1 minus P, which I'm sure everybody in the audience has worked with before. And I just try to tack on some something that depends on the audience size. N, A is a parameter, over here B is a parameter. And I work through that calculation. Well, it's just what I had before. Instead of A minus, before A was 0. Now A is some number, positive or negative. But it doesn't change the fact here that you still want to maximize P times 1 minus P. That is, you still want to maximize the per capita profit. So that really doesn't do anything for you. It gives you little curves that have a different shape than we saw before, slightly different shape, but it doesn't change the fact that the price is still going to be independent of demand. Okay. So now you say, and several people have mentioned, can you write down a model where the slope of the demand curve depends on N and get an answer out? And the answer is yes, you can do that. Here's the example. I just take, instead of having P times 1 minus P, I have P times 1 minus P over N. Okay, so now what's that going to do? Well, that's the demand function here, this 1 minus P over N, and the demand function slope is going to change as you change N. Okay, to make this algebra work out simply, you have to stick a P over here. I don't really have a good interpretation of that, but that gives you a nice closed form solution. And what's going on is the larger the sample size, or the larger the audience size, I really should say, that gives you less price sensitive demand because you've taken that P and you've divided by N. So maybe with small samples, you get low income people, but larger samples pull in those high income people. They're hard to find. And so that will give you the kind of model that you are asking for, namely one where there is a lack of the separability, which I find very attractive, but I agree. You have to look at what happens if it's separable and at least have some examples of what happens if it's not. And the Grossman-Shapiro model is similar to this, those of you who've seen that model. And I'm almost done here. Oh yes, last slide, conclusion. Increased cost of informative or persuasive advertising does not affect product prices. It makes a firm less likely to advertise, or reduces the amount of advertising that's gone on because it's become more costly. But it's not allowing prices to change, because just as I've said several times, if you could change prices and increase profit, why didn't you do it already? The only cases where you won't want to do that is where the price, the profit maximizing price, in fact, depends on the audience size. So left for future work. What about consumers? And I will make one remark about consumers. Informative advertising leads to lower prices, which is good. But according to the CMA and to other observers, the ad load, that is seeing a lot of ads, is bad. So a monopolistic provider of these audiences would raise prices and reduce output, but that has a positive effect on consumers to some degree, okay, because they don't have to see as many ads. But it has a negative effect in that those ads are higher, and to the extent that those ads have a higher price, and so the consumers are getting less information. And so that would be the next stage of try to bring the consumers in, and then maybe you can get a full grand model where you look at what happens to the audience provider, what happens to the product prices, and what happens to the consumer. But I'm not there yet. Okay, I'm going to stop sharing. And there. So thank you for your questions. I'm looking to see if anybody has a hand up.
Yeah, I have a hand up. I wanted to continue this, probably from your perspective, never-ending theme of fixed versus marginal cost of advertising. And I think that a point and then a reference, there's also which model a platform prefers. So does it prefer to get its customers acquired? Does it prefer to do per click business model, or a kind of cost per impression, if you like, a fixed cost like you have? And there's, in the same line of work as Butters, Grossman Shapiro, the ones that you cite, there's a nice EJ paper by Bay, Morgan, and Gao, which looks at those two things in a price competition framework and comes to the conclusion that if you let a platform choose, if you like, a two-part tariff consisting of a fixed component and a marginal component, they put all the weight on the marginal component, which would then be in your key profit expression, P minus C minus this new cost. It's just a more marginal cost. And then the separability isn't there, and so on. So I just want to mention that platform incentives could be pretty important here, rather than just assuming it's all fixed cost.
Okay, so remember, there's always two costs. There's the cost of the product and there's the cost of the marketing. So the cost of the product might as well be constant. That's just the marginal cost. So you can make it, well, formulas become simple if we make it zero. But the other cost is this marketing cost, and you could make that marketing cost a fixed cost plus a variable cost, no problem. I mean, the equilibrium, in fact, I have some notes on this. I didn't put it in this presentation, but you could also look at a monopolistic competition model where firms have different fixed costs, and then the equilibrium condition is going to be the marginal firm has got a profit of zero. And the ones who have a lower fixed cost, they're in the market. And the ones that have a fixed cost that's higher, eventually they're not in the market, and there's a marginal firm that just makes zero profit. So you could do that. I don't think that changes the model at all. It doesn't change what you really have to change the models. You have to have a way that price changes when the audience size changes. Bay, Morgan, Gao. Okay. In fact, I think I know all of those three, or at least two of the three people. So I may even have read the paper 20 years ago. I don't know, 30 years ago. Anyway, and I think we want to get away from this click thing, because I don't care whether it's a click or whether it's a TV commercial. What happens is I'm getting this, this audience, and I'm looking at purchase. Okay. Whether they came through, your proposal is very reasonable. You could look at different ways of pricing that audience size, but that M of N, at least in everything we've done, is an arbitrary function. It's not, it doesn't really matter whether it's fixed or marginal. You have a different equilibrium. And one thing I should say is, even though people think that Google has a cost per click model, is really a cost per impression. It's a cost per expected impression, because you've got that quality score, what we call a predicted click-through rate, And what it means, see, when you think about it, is the search engine or the content provider has ad space to sell, and the merchant who's contemplating buying that space only wants to pay per visitor. So it's like, I want to pay in dollars and you want to receive pounds. It's here, I want to pay for clicks and you've got impressions that you can offer. So the auction, is efficient if you look at that cost per, it's like saying, here's price and here's quantity. What I care about is not price. What I care about is price times quantity, revenue. Same thing for the Google auction, but that's totally separate from the rest of the talk. Yeah, it's a footnote. I think the interesting question would be how many different ways, or what is the reason, or how can you model how price depends on audience size? Because if price doesn't depend on audience size, we get the talk I just gave, namely everything's really, really simple. But I think it's a natural baseline. That would be where I find that plausible starting point. Other questions? There's a whole bunch of chats down here. Let's see, what do they say? Would you feel the same way if price was in the ad?
It's a fairly long chat.
Oh, okay.
But I mean, just we can talk about it after, but Volker has his hand up, and then
okay, let's go with that.
Yeah, I'm just wondering, one sort of old research trend you didn't mention, which might have something to say, sort of, John Sutton's endogenous sunk cost, right? So if you think about advertising as, I guess, raising consumers' willingness to pay, and then a bit in the spirit of your free entry equilibrium you just mentioned, although in the context you mentioned, the context of monopolistic competition, there it's actually not so clear in these kind of Sutton type model. If you sort of think about now, advertising cost is changing somehow, the mapping from, expenditure to quality, what the equilibrium effect is going to be. In fact, it could be that you reduce, in some sense, the cost of an ad, but in equilibrium, firms are going to spend more on advertising. But then in the long run, might have the effect that actually fewer firms are going to be present, because of free entry and exit. And so, in fact, that actually could have the effect on price might ultimately come. In the Sutton model, it's all fixed. It's this fixed advertising cost, but it's about market structure as well, right? Somehow the extent to which you have this escalation in these advertising outlays is going to affect market structure, and market structures then can affect prices.
Yeah. Okay, I haven't investigated a Sutton type model, but it's a good next step to do. I should look at that. There is this famous quote from Michael Spence, who said, in these days, the biggest fixed cost a company might have when it enters a market is the advertising cost of letting people know their brand is there. And you see that is a very important and I think profound observation, because if you look at a company like Amazon, which at one time only sold books, it wasn't selling goods or anything like that, they had to make it known that you could buy products on Amazon. Or you look at companies like the Money Supermarket in the UK, they had a tremendous ad campaign, huge ad campaign, just to establish their brand identity. There were ads in the computer, there were ads in the newspaper, there were ads in the magazine, there were ads on the billboards, on the subway, everything else. So whenever you're entering, whenever you got an entrant coming in, their first and foremost and most important thing they can do is let consumers know I'm here. You can buy streaming video from me, like Netflix. And what Netflix did when it entered the market is there were banner ads for Netflix everywhere. They were buying every available ad space they could online, because that was the market that they wanted to reach, of course. And then people said, well, what is this Netflix thing? And they click on it and then they find out what Netflix is. And after that, very real sense, you have to advertise, spend on advertising now, so you don't have to spend on advertising later. You've established such a strong brand that people navigate directly to Netflix or to Amazon or to Money Supermarket. They don't go through Google or any other search engine. I know what I want, I'm going to go to Amazon. So that's the thing. Pay now, makes your life a lot easier later on because you've established a big brand. Now, even brand advertising, I mean, Coca-Cola, even though there's 1 billion Cokes consumed a day, it's amazing. They spend money on brand advertising, but mostly now they're spending money on all their new products rather than just their traditional product. People already know it exists. So go ahead.
Yeah. Somewhat returning to the earlier conversation, but also almost one of your first examples is Google Shopping.
Yeah.
But a lot of Google Shopping is ordered on price, right? So this is really what I think has been kicking around a lot, which is if I have an advertisement and I pay some sort of fee for that, and the price is displayed, and I'm trying to somewhat distill what's been in this chat, that will affect the amount of searches. So if there's a per click fee, even if there is quality weighting that happens to be on the overall behavior of consumers that go to this website, there is some aspect in which my price affects my traffic, and so it affects my ad costs.
Yeah, but the question should be, does it affect our probability of purchase? And this click
it would be the ratio between the two that would be important, right? Whether your conversion rate depends upon your price as well.
So all these examples I cited, these product listing ads and Amazon's product ads and so on, they all have the same structure. And why do they have the same structure? Because all the firms have a standardized way to upload information about prices and features of their product. So there aren't 15 different ways to do that. There's one way to do that, really. And everybody uses the same way. So it's just a way to make it easy for consumers to find out the prices of products. And once they see the prices and products, they decide whether to buy. And that's going to be in that model where the value of the consumer for the good exceeds its price, he purchases. If it isn't, it doesn't. And you can figure that out without looking at all these other things. I mean, you need to know the price because you need to know how much to type into the payment box, but that's Amazon and its boards and experiments have determined what the optimal price is. And as the market scales, that really doesn't change. Oh, by the way, I should say, this would be different if it wasn't cost and marginal cost. There are returns to scale. Then, of course, the audience size and the price would be related. And it wouldn't happen if there was a network effect. Because if there's a network effect, because, wow, I think that new hat is very cool, I want to get one like that too, then that would change with scale. So those would be models where you would get this, get somewhat different results.
Okay, so thank you for a great presentation. I'm going to cut the recording here.